In this video, we will look at what a pavement is, the different types of pavement and where each is used. The pavement is the surface of the structure that supports the traffic loads and provides the running surface for vehicles. That is, the part of the road that is above the subgrade. This photo shows a section through a flexible pavement. You can see there has been several surfacing layers applied over the years. The top surface is presently asphaltic concrete. You can also see a 150mm thick base course layer beneath the surfacing. Beneath that is a clay subgrade. There are two main different types of pavement used in New Zealand. They are flexible and rigid pavement with some variations in between. Flexible pavements support the road loadings using sub-base and base course layers with a waterproof surfacing. The surface may be chip seal or asphaltic concrete. The road loadings are transmitted and distributed down through the base course and sub-base layers by contact between aggregate particles. The surface is flexible in that it can actually move under traffic loadings. Rigid pavements are constructed of a reinforced concrete slab or a dense asphaltic concrete layer greater than 100mm thick, sitting on an unbound granular sub-base or base course. The concrete slab is sometimes the road surface or, more commonly, a layer of asphaltic concrete is placed on top of the slab. The road pavement is the main component of the road. This means it has the most bearing on the quality of the road. Quality in this case is how well the road meets its requirements. There are a variety of requirements for the road and the pavement specifically. One of the main requirements of the pavement is to support the traffic loads and reduce them down to levels that can be carried by the subgrade without deformation or failure. The pavement needs to support these traffic loads for long periods of time without breaking up. Specifically, the whole pavement needs to resist the normal stresses from the weight of traffic and the shear stresses from vehicles accelerating, braking and turning. The surfacing and base course surface in particular are especially prone to damage from traffic loadings and need to be designed to resist them. The pavement needs to provide a comfortable ride, which means that the road surface is even without depressions or humps. Once again, it needs to be able to maintain this even surface for long periods of time without maintenance. Once depressions and humps start to form, then vehicles bouncing on the road create additional impact loads that accelerate the pavement deterioration and eventual failure. The road surface needs to be able to provide skid resistance by having good traction between the vehicles and the road. It is this traction that allows vehicles to stay on the road even when turning, braking and accelerating. Over time, the road surface can be polished by traffic movements, resulting in a loss of traction, so surfacing in contact with the vehicles needs to be selected to resist being eroded by repetitive loading and weathering. Water on the road can result in less contact between the vehicle tires and the road itself, which can result in vehicles losing control or hydroplaning. Additionally, ponded water on the surface can significantly slow vehicles and may result in the driver losing control. This is especially a problem when depressions form on the road and the ponded water is deeper. Water soaking into the pavement structure can result in the structure not being as strong as it needs to be and failing. Therefore, the surface of the road needs to be watertight to prevent the intrusion of water into the base course. The extent of the road and road markings need to be clearly seen in all weathers. Head-on crashes can occur when drivers cannot see the road centerline, or cars can lose control in unsealed road verges if they cannot see where the road edge is. The road also needs to have low reflectivity, which means that sunlight and street light reflection off the road surface does not dazzle or blind the driver. This is especially a problem when the pavement is wet. The pavement needs to be affordable both in construction and in the maintenance required over its life. New Zealand has about 94,000 kilometres of road, and the length of road per person in New Zealand is one of the highest in the world. So we have a relatively small number of people funding a large number of roads. We do this by using designs, materials, and methods that allow us to build and maintain roads that meet our requirements at a reasonable cost. There are a number of differences between flexible and rigid pavements, as summarized in this table. These differences can influence the quality of the pavement type in a particular use, that is, how well it meets the requirement of that particular situation. For example, in this slide we will see that rigid pavements may provide a higher quality solution for heavy traffic loadings, while flexible pavement may be a better solution for most other roads, mainly by virtue of their lower cost. Looking at construction cost, rigid pavements are more expensive to construct than flexible pavements, as reinforcing steel and concrete cost more than the aggregate used for flexible roads. A minimum rigid pavement costs about $100 to $250 per square meter to construct, whereas a minimum thickness flexible pavement costs about $20 to $25 per square meter. However, the rigid pavement requires much less maintenance. Concrete pavements can last for decades with no maintenance being required, except for repairs and replacement of a surfacing layer, if there is one. The base course and subbase of a flexible pavement require much more maintenance, usually requiring significant maintenance or renewal every 10 to 20 years. The rigidity of rigid pavement can cause more road noise than flexible pavement, given the same surfacings. However, this can be addressed using thicker asphaltic concrete surfacings. Also, motorways and industrial roads that use rigid pavements are often removed from residential areas where road noise would be a significant nuisance. Some parts of a road may have services such as pipelines, power, or telecom cables running under them. If these services need repairs, then the road above needs to be removed to gain access to the service. This is much easier to do with a flexible pavement, which can be dug out with an excavator. However, concrete pavements need to be cut and removed, and replacing them afterwards creates a weak spot in the pavement. New Zealand experiences significant earth movements such as earthquakes or long-term creep. A flexible pavement is able to move with the underlying earth movement. This usually creates depressions or humps in the road surface, but often the road is still usable. Rigid pavements crack and dislocate more readily under earth movement and are more likely to become unusable more quickly than a flexible pavement. Basically, it works out that flexible pavements are the best solution for most roads in New Zealand and are the most common pavement type. However, rigid pavements are a more economical choice for roads which are very heavily loaded, such as motorways or major roads that have a high number of trucks or other heavy vehicles, such as ports and heavy industry areas. These heavily loaded roads can break up more quickly, and so using a rigid pavement works out to be less expensive, as they are better able to withstand the heavy loadings and therefore would not need so much maintenance. It should be noted that maintenance on a road causes traffic delays as well. So having a road with lower maintenance requirements also reduces traffic disturbance over the life of the road. Rigid pavements also work out to be less expensive when a small section of road is required, such as a driveway or a footpath. This is because the materials, equipment and labour required to construct a reinforced concrete road are more readily available than that required for a flexible pavement. So when building a driveway or footpath, it is not worth bringing in specialised equipment required to build a flexible pavement when there are only a few hundred square metres of road to construct, and so concrete may be best.